What is a relation? So last class, I can't remember how long that was ago, maybe like 2 or 3 weeks. We talked about relations and the different types of relations. So a relation is a set of ordered pairs, right? So I'm going to highlight the things that are important. A set of ordered pairs that shows a connection between elements of two sets. So a set of ordered pairs, it shows a connection between elements of two sets. In simpler terms, a relation describes how inputs, your x values, are related to the outputs, which are your y values. So relations can be represented in different ways, such as a set of ordered pairs. That's like the coordinates, right? So, for example, this is the set of 1, 2, 2, 4, 3, 6. It can be represented in a table, it can be represented in a mapping diagram, or even a graph. So, if we're looking at the set of ordered pairs here, can you spot a relationship between the x and y coordinates here? So the first one is 1, 2, the second one is 2, 4, and the third one is 3, 6. Anything? Can you spot a connection? What is the connection between the x and y coordinates? Because each of these are coordinates, right? Your first coordinate is your x, and then the second value is your y coordinate. So you have 1, 2, 2, 4, and 3, 6. Can anybody tell me what the connection between the x and y values here is? Anybody? Do you see a pattern? Like you have, I'm gonna write. So here it says it can be written in a set of ordered pairs or a table, right? So I can put this in a table as well. So if I had a table, right, I'll have my x values and then I'll have my y values. So the x values here, you have 1, 2, and 3. And then the corresponding y values are 2, 4, and 6. Athena, can you spot a connection between the x and y values here in this table? Is there a
Um,
pattern?
they appear to be mostly like halves.
The x values are half, right? Yeah, so the x values are half of the y values. So if x is half of y, then that means y is twice x. So I can represent this relation here. I can say y is equal to 2x because for every x value, y is equal to 2 times whatever the x value is. Look, in the first one, when x is 1, y is 2 times 1, which is 2. In the second one, when x is 2, y is 2 times 2, which is 4. And then in the third one, when x is 3, y is 2 times 3, which is 6. So the connection or the relation here is that y is equal to 2x. All right. So here, this is your set of ordered pairs when it's written like coordinates. Here is a table of values. You can also have a mapping diagram. So last time we looked at mapping diagrams. That's like the two ovals with the lines connecting them, right? So you'll have your domain and your range or your codomain. So in here, this is your x values and this is your y values. So you'll have 1, 2, 3, and 1 maps on to 2, 2 maps on to 4, and 3 maps on to 6. All right, so that's the set of ordered pairs, the table, the mapping diagram. And then in terms of a graph, I can represent the relation y is equal to 2x in terms of a graph as well. So let me just show you all. Let me see if I could pull up Desmos quickly and show you guys what the graph y is equal to 2x looks like. Give it a few seconds. All right. So y is equal to 2x. That's the graph of y is equal to 2x, right? And on this graph, when x here, x is 1, y is 2. Look, if I were to put my point over there, that's when x is 1, y is 2. when x is 3, y is 6, right? And when x is 2, y is 4. So you see? So any point on this line, the relationship that would be, well, the relation or the connection between the x and y values is that y, sorry, I'm missing myself by accident. Yeah, y is equal to 2 times x. So even like if I were to put the point at this coordinate here, that coordinate is when when x is negative 1, y is negative 2. I'm trying to see. So any point on this line, the relation between the two coordinates will be y is equal to 2 times x. So there I've shown you that a relation can be represented in form in 1, 2, 3, 4 different forms as a set of ordered pairs, a table, a mapping diagram, or even a graph, right? And at any line, I could use any point basically. I could use any point here, and once I know the x coordinates, I can figure out what the y coordinate is. So, like for example, if x was 10, then the corresponding y coordinates will be 2 times 10, which is 20. And that point 10, 20 will be on the graph, right? Let me show you. Let's go on the graph and see. So let's find 10, 20. So when x is 10, let me zoom out a little bit. When x is 10, look, y is 20, right? Zafira, you there, honey?
Yeah, I was
What
glitching up
about
just now.
what about when x is 5? What would be y?
10.
10. Good. Genesis, what about when y is 24? What would be x?
12.
12, right? So guys, you see it, right? You see the relation there. So I want you all to start to make connections between what you're learning. So anytime you see a graph, the graph represents some relation between a x and a y value, right? Coordinates are just not random points. Especially if it's in a graph, you can have random points on a Cartesian plane, but if you have a straight line or even a curve, it's representing a relation, right? So a curve will be representing a quadratic function. But a straight line is a linear function, which is a one-to-one relation. And any point, you could find the points. Once you know the relation and you know one point, like you know one coordinate, sorry, you could figure out what the other coordinate is, because once you know what the relation is, you can figure that out. Just like we know that the relation that is being represented by this straight line graph is y is equal to 2x. And that means that whatever x coordinate you have, when you multiply it by 2, you're going to get the y coordinate. So that's just some context for you. And this is stuff that you already know, but I'm just refreshing your memory a little bit on it, right? So a relation can be represented in terms of a set of ordered pairs, right? A set of ordered pairs, a table of values, a mapping diagram, or a graph. All right. And in CSEC, you can be assessed on any one of those representations. Sometimes they give you a table of values and you have to like fill in missing parts. And when we look at questions, you'll see them, right? Let's move on. So the types of relations, we've done this before, but we're going to look at it again, right? You have a one-to-one relation, which is when each input, your x value, is paired with exactly one output or one y value. So all linear functions, all linear equations or all linear relations are one-to-one, right? Because no matter what, you'd only have one x value and one being mapped onto exactly one y value. Okay, you also have a one-to-many relation when you have a single x value related to multiple y values. So for instance, if the relation that I'm looking for is, let's say, multiples of, so x is a multiple of y, right? This is the relation that I'm looking at. Well, x is a multiple of y. Like, for example, if I had 12, right? Then 12 will be mapping on to 12 is a multiple of 1, 2, 3, 4, 6, and even 12, right? So 12 is this relation here, x is a multiple of, will be a one-to-many relation because one element in the domain maps onto more than one element in the codomain or the range. So that's what a one-to-many relation is. I thought that one-to-one is self-explanatory. I know you understood that one, but still, I'll still show you one. Let's say we had the relation is y is equal to x plus 2, right? No matter what, every element here will only map onto one element in the every element in the domain. Your x values are your domain and your y values are your codomain or your range. Every single element here, no matter which numbers you put, say -1, 100, and 0, they're going to map onto one and only one element in the range or the codomain, right? So -1 will map onto 1 because -1 plus 2 is 1. 100 will map onto 102. 100 plus 2 is 102. And 0 plus 2 is 2, right? So all linear relations are one-to-one relations. Okay, then you also have a many-to-one relation. Multiple x values share the same y value. So this can be, what can this be? This could be a very, very common example of a many-to-one relation would be like if we had one saying y is equal to x squared, which of course is a quadratic, right? It's a quadratic because the highest power of x here is 2. And that is the criteria for something to be a quadratic. So y is equal to x squared, right? So let's say we had -1. Actually, let's start with -2. So if we had, and I'm putting it in a mapping diagram because I find it's easy to spot in a mapping diagram. So if we have -2, -1, 0, 1, and 2, right? And these are your x coordinates or your x values. And then you have your y values now. Well, if y is x squared, -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1 and 2 squared is 4, right? So -2 will map on to 4. 1 will map on to 1. 0 maps on to 0. 1 maps on to 1 and 2 maps on to 4. So as you can see here, this is a many-to-one relation because you have multiple x values mapping onto sharing the same y value. So that's a many-to-one relation. And then you have a many-to-many relation. Multiple x values are paired with multiple y values. That could be, what could that be? Possibly is a factor of factors, right? So like, let's say we have 2, 3, and 4, right? And then if we're looking at factors, 2 is a factor of, and let's put a restriction on the domain for this one because of course 2 is a factor of many numbers. So is 3, so is 4. So let's look at numbers less than 20, right? 2 would be, oh gosh, I'm taking off 2 because 2 has to be too many. So if we're looking at is a factor of 3 is a factor of 3, 6, 9, 12, 15. What else? 18. And let's do 3 and 6 instead, actually. And you have 6, right? So this is x and this is y. Well, 3 is a factor of 3, 6, 9, 12, 15, 18. 6 is a factor of 6, 12, and 18, right? So this is a many-to-many relation. You have multiple x values paired with multiple y values. All right. So that's just a recap, guys, on the different types of relations. Now, in terms of a function, functions are special types of relations. Only two of these relations that we just discussed here are considered functions. Right? So a function is a special type of relation where each input, so each x value, is paired with exactly one output or one y value. So this means that a one-to-one relation is a function because it's one x value being paired with another y value. And similarly, a many-to-one relation is also a function because in a many-to-one relation, it still is only one x value being paired to multiple y values. Right? So like those, so that the quadratic, for instance, was a function because you had -1 and +1 being paired with 1 and then 0 and then -2 and 2 being paired with 4, right? And then you have, well, a one-to-many or a many-to-many relation is not a function because one x value has multiple outputs. So you have to know which two relations are considered functions. They are one-to-one or a many-to-one. Only those two relations are considered functions. And there are different tests that we can apply to see whether a function, a graph represents a function or not. The vertical line test tells us if a graph is a function. So the vertical line test, you just draw a vertical line on any point on the graph, and that would tell us if the relation is a function, right? So if it touches the graph in one place, it would be a function. If, however, it cuts the graph in more than one place, it is not a function. So let's look at that on the graph now. So let's look at the vertical line test, okay? Now, this was the function from before, y is equal to 2x. Now look at this, guys. If I were to draw a vertical line at any point on this graph, no matter what, that graph is only going to cut that line is going to cut the graph at one point and one point only. And because it does that, we know that this relation y is equal to 2x is a function, right? Similarly, let's say we have the function y is equal to x squared. This is the graph, y is equal to x squared, right? Now, if I draw a vertical line again, no matter where I draw this vertical line along this graph, it will only cut the graph at one place and one place only. See? Only one place it touches the graph. So this is a function, all right? Let's do another one. Let's say I were to draw I'm going to draw the graph myself. So let's say I have a graph that looks like this. Look at what happens when I draw a vertical line there. Do you see what happens? When I draw a vertical line, this line is cutting the graph at 2 points. So therefore, this graph fails the vertical line test, and so it is not a function. This graph does not represent a function because it fails the vertical line test. The vertical line test, here, when I apply a vertical line anywhere along this graph, if I put a vertical line, right, it's going to cut the graph at more than one place. And once that happens, this graph does not represent a function. Okay? So that's something to know as well. Very important. Okay? All right. Now, there's also another. I don't think it's in this one. I don't think I put it here. No, I didn't. So I want to show you. Now, remember, a function could be a one-to-one or a many-to-one relation, right? In these notes, I only talk about the vertical line test to determine whether whether a graph represents a function or not. But you also have the horizontal line test, and the horizontal line test tells us whether a function is one-to-one or many-to-one. Not sure that you have to know that for CSEC, but I'm still going to tell you guys I'm still going to put it in here, what it is, right? So the horizontal line test tells whether a function is one-to-one or many-to-one, right? So using the same two graphs that we know, we've established our functions, right? The first one was y is equal to 2x. This graph here represents the function y is equal to 2x. Now we already know that it is a function because it passes the vertical line test. A vertical line cuts the graph at only one place. Now let's see if it's one-to-one. Now if I were to draw a horizontal line, at any point on this graph, it is in fact going to cut the graph at one place and one place only, right? Look, so a horizontal line drawn along any part of this graph will cut the graph at only one place. So this tells us that the graph y is equal to x is a one-to-one function, right? Because it passes the horizontal line test. Now, similarly, or I should say on the contrary, y is equal to x squared, though it is a function, it is not a one-to-one function because, as you can see, if you apply a horizontal line to this graph, look what happens. It cuts the graph at more than one point. So like here and here. So this is not a one-to-one function. It is a many-to-one function. So although it passes the vertical line test, it is a function. However, it's not a one-to-one function. It's a many-to-one function. And the reason it's a many-to-one function, guys, x squared, right? Every value, the square root of every single number will have two square roots, right? Any number will have two square roots, a positive square root and a negative square root. So like with the x squared, and we just went through this, if you're looking at the graph of y is equal to x squared, right? When x is, and I'm going to put this in a table of values, when x is -1, or let's say x is -2, y will be -2 times -2, which is 4. When x is -1, y will be -1 times -1, which is +1. When x is 0, y is 0. And then when x is +1, y is also 1. When x is +2, y is also 4. So as you can see, you have the same y value, 4, connected to two unique x values, -2 and +2. And we can see that on the graph as well. Look, when x is -2, sorry, look, y is +4, right? And then when x is +2, y is +4, all right? So this function is a many-to-one function. Okay, so that's also something to note. Of course, I'm going to send you guys these notes afterwards because I want you to just save them if you want to copy them over into your notebooks, because you find that when you write, you remember, do that. If you prefer to print it out, if that's available to you, you can do that as well. If you want to just save paper and save ink, well, you could just have it on your device, right? And even if you don't have a device to store it on, it's on the Google Classroom for your use at any point in time. Okay. So the two tests that are important with functions are the vertical line test, which determines whether a graph is a function or not. And the horizontal line test, which tells us whether a function is one-to-one or many-to-one. Right? Okay, so a function is a rule that assigns exactly one output to each input. That is, a function is a one-to-one or many-to-one relation. That's what we just spoke about. I'm highlighting it. Sometimes I hate to highlight because then my whole page I just find sometimes everything needs to be important, so I just don't even bother. Examples. For f of x is equal to x plus 3, here, when you input x, you get exactly one value for f of x, right? Because this is a linear function. It's a linear function because the highest power of x is 1, right? So in a function, when the highest power of x is 1, it's a linear function. And that is so for any graph or equation, right? Once the highest power is 1, it's a linear. If the highest power is 2, it's a quadratic. And it's also a function, except it's a many-to-one function. Okay, so functions are commonly written in function notation. Actually, let's take a few minutes and I'm going to ask you all some questions to see if what you all remembered. All right, I'm starting with you, Ari. Ari, you there, honey?
Yes, I am here.
Tell me, what are the 4 types of relations?
There's one-to-one, there is one-to-many,
Yeah,
many-to-one, and then many-to-many.
thank you. Isabel, which 2 relations are considered a function?
I think it's one-to-many and many-to-one.
It's one-to-one and many-to-one. So always to one, right? Always to one. So it's many-to-one or one-to-one. A function is when you have one input. Sorry, every x value maps onto one and only one y value. So it's always going to be the relation that ends with one, right? So it's going to be one-to-one or many-to-one. Okay. Genesis, how can we represent a relation? What are some different ways that we can represent a relation?
In a graph or in a table.
Yeah, in a graph or in a table. Athena, do you know any other ways that you can represent a relation? So, Genesis said in a graph or in a table. Where's my girl Athena?
Um, you could represent it in, what was it? I was gonna say graph, but then I realized.
So it's a graph. Anybody knows? So a graph, a table. How else? How else can we represent a relation? In a table of values on a
A
graph or
mapping
a mapping
diagram.
diagram. Yeah, a mapping diagram. Or we can list this as a set of ordered pairs. All right. Okay, good. Zafi, what is the vertical line test? What does that tell us? The vertical line test.
I don't know how to say it, so I might use a lot of it.
Okay.
So it's like to see if it's a good thing for a one-to-one relation. Kind of like
So it tells us, all right, it tells us whether a graph is a function or not. So what would we be looking for? So we know the vertical line test tells us whether a graph is a function or not. So how would we know if a graph passes the vertical line test or if it fails it? What are we looking for in particular?
if it goes through
The
the
graph.
the graph
Mm-hmm.
at more than one point.
So if it goes through the graph at more than one point, is it a function or is it not a function?
Not
Good, correct. Good. So if it's if you use a vertical line and it goes through the graph at more than 1 point, it means the graph has failed the vertical line test and that graph is not a function. Thank you, Zafi. What about the horizontal line test? Kaylin, what about the horizontal line test? What is the horizontal line test? What are we looking for with the horizontal line test? Kaylee, are you there, sweetie?
It tells you if the function is like 1 to 1.
Mm-hmm. Or many to one. Good. So how would we know if it is a 1 to 1 or many to one? What are we looking for? That's for you again, Keelan. You are correct in that the horizontal line test tells us whether a function is 1 to 1 or many to one. But what in particular, when we draw the horizontal line, what are we looking for? Anybody? Unless Kaylin, you're ready, unless you know.
Miss, I forgot.
Okay, so just like with the vertical line test, wait, anybody knows? Anybody knows what is the criteria, what we're looking for with the horizontal line test? If a horizontal line cuts the graph at more than 1 point, the function is many to one. All right. And if it cuts it at only 1 point, then it is a 1 to 1. Okay, girls, good. I'm just writing this in before I send it to you. If the horizontal line cuts the graph at 1 point, the function is 1 to 1. Good. All right. Let us take a short break, girls. And then when we come back, we're going to go through function notation. A function, as we discussed, is a 1 to 1 or a many to one relation. A function assigns exactly one output to each input, right? So think 2, 1, like this part, 2, 1, 2, 1, right? So you have many to many, 1 to many, 1 to 1, or many to one. 2, that's a mapping to just one and only one output is, well, those two will be considered functions, right? So let's look at function notation. Functions are commonly written in function notation as f, and in brackets you will see x. And we say this, how we would read this, we will say f of x, right? So this is f of x. That's how we say it, right? Where f represents the function name, x is the input, also called the domain, and f of x is the output, also called the range. So, for example, if f of x is equal to 2x plus 5, then f of 2 means to substitute x is equal to 2 into the function. So basically, what this is saying, f of x is equal to 2x plus 5, that is the rule or the connection between the x and y values, right? So your f of x is really your y values, right? So like if I were to write this, so I could do it in a mapping diagram, or I could do it in a table of values as well. So if I'm looking at a table of values, right, and I have x and my f of x values, my f of x values are really my y values, okay? So when x is 2, if the relationship that maps x onto y is 2x plus 5, then your f of x value is what is the value of f of x when x is equal to 2? So that means that I need to substitute 2, x is equal to 2, into the relation 2x plus 5. So wherever I have x in the function, I will replace it with 2. So I'll say 2 times 2 2 times 2 plus 5, which would be 4 plus 5, which is 10. So my f of x value when x is 2 is equal to 10. Or I can also say that f of 2 is equal to 10, right? So when x is 3,
Miss, 4
the
plus 5
value,
is equal to
oh
9.
gosh, 9, thank you. Gosh, Gil, thank you so much. Yes, you're right. Thank you, baby. 9. Good. Ari, work out the next one for me because clearly I something wrong with me. Right? So when x is 3, Ari, can you walk us through what f of x will be equal to when x is 3? Ari, you came in clutch there.
Would it be 11?
Tell us why.
Because 3 times 2 is 6, and then 6 plus 5 is 11.
That's right. Good. So f of x will be 11 or y is equal to 11. Nia, you there?
Yeah, miss.
Nia, what about when x is negative 1? What would f of x be equal to?
When x is f of x. Wait. When minus x, like the equation must have sound like the full thing.
The full thing, what the answer will be, what f of x will be equal to. You could tell us what the equation is, though. Like you could tell me.
Okay, so it will be f and then minus 1 in the bracket, and then
Mhm.
it would be equal minus 1, and then
No,
minus
it's 2
1
times
again,
x.
but like,
F of negative 1 is 2 times negative 1 plus 5.
wait. Oh, I really did the wrong thing. Okay, right. So then that would make x equal to 3.
Not x, f of x.
f of x, f of
Yeah,
x equal to 3.
correct. Good. Let me see. Genesis, what about when x is 0? What would f of x be equal to?
It will be f open brackets 0
Mm-hmm.
is equal to 2 by 0 plus 5,
Beautiful.
7.
That's right. That's right. Atina, what about when x is 100? What would f of x be equal to?
So hold on a second.
Mm-hmm.
I would say 205.
That's right. It is 205 because it will be f of x is 2x plus 5, which means 2 times x plus 5. And if x is 100, that would mean 2 times 100 plus 5. So with your functions, it's really just substitution, right? So f of x is the function that is applied to x, which is the rule that is applied to x. So in this case, the function is such that you are doing 2 times x plus 5. So no matter whatever value you put in there, what you're going to do to get your f of x value or your output, you would say 2 times x plus 5, right? And that's what we did here. Right. So then you can also, in the same way, how you can find what is the value of a function when x is a certain number, you can also find the value or the the number itself when you have what f of x is equal to. So for instance, when we just started, right? Let me see if I can, let me share the whiteboard for a second here. We're going to look at the whiteboard and then we're going to come back to this. Girls, I'm showing my whiteboard. So if you're not seeing it, please let me know. But my whiteboard should be on the screen here. All right. So let's say that f of x, and we could use any letter. Yeah? We could use any letter to represent the function. We could use h of x or g of x. We can use any letter to represent the function. So like if we have f of x is equal to, let's say, 3x minus 2. This is a linear function because the highest power of x is 1, right? So it's a linear function. It's a one-to-one function. All linear functions are one-to-one functions, right? So let's say I want to find out the value of the function when x is equal to 1. That means I am finding f of 1. So f of 1, I would say 3 times 1 minus 2. So 3 times 1 is 3 minus 2 is 1. So the value of the function when x is 1 is equal to 1, right? Or I can say that the image of 1 is 1. All right. So this value, your f of x values, those are those values will belong to your images, right? Or the image set. So let's see when x is -3. When x is -3, f of x will be equal to 3 times -3 minus 2. So that would give me 3 times -3, which is -9, and -9 minus 2 is -11. So what I can say here, how I can explain this, or how I can describe this whole thing here, I can say that the image of -3 is -11, right? Because f of x is equal to -11 when x is -3, or f of -3 is equal to -11. So this is called the image of the value -3. All right. Sorry, excuse me. Safi, you there?
Miss.
Safi, what about when x is 2? How would I find f of 2? It would be equal to what?
It would be equal to, oh my gosh.
So the function is 3x minus 2. That's the function. So what would it be? What would be f of 2?
I'm still a bit lost on doing this, even though it's simple. I'm still a bit lost.
That's okay. Let's do it together, right? So if the function is 3x minus 2, to find out what f of 2 is, I want to know what will this be equal to when x is equal to 2. So in other words, when I substitute 2 into this equation, into this expression, 3x minus 2, what would I get? Because this here, 3x minus 2 means 3 times x minus 2, right? So if I want to know what it would be equal to when x is 2, I am substituting 2 into the expression 3x minus 2. So wherever I have x, I am replacing that with 2. So it would be 3. Yeah, so it would be 3 times 2 minus 2, like this. And then I work it out. So 3 times 2 is 6, and 6 minus 2 is 4. So f of 2 is equal to 4. And if I had a mapping diagram, 2 will map 1 to 4. So let's do one. Let me give you another one, right? If I wanted to know f of 10, right? It would be, what would it be? So this is when x is 10. So what would be my first line?
3
Mm-hmm.
by 10. The
That's
10 being
right.
in brackets
Yeah,
minus 2.
that's right. Which will be equal to
30 minus 2.
mm-hmm. So the final answer, f of 10, is equal to
Oh my gosh. Um,
30 minus 2,
28.
28. Do you understand now?
Yeah.
Good. So it's substitution, girls. Finding the value of a function when you know an input value is actually just substitution. That's all it is. You substitute the value into the expression, right? So at this point, I actually want you all to do a short exercise for me. Take a picture of this if you didn't already, or if you didn't write it down, take a picture of it because this is the method that you use to find the value of a function given x, whatever x is equal to. Okay, so I'm gonna give you all a function here. The function is f of x is equal to 12x plus 5, right? And you are finding for me, so so this is question 1, and you're finding A, f of 2, B, f of negative 1, C, f of 0, and then D, f of 1/2. Okay? So you're finding for each of these are basically you're finding the value of the function 12x plus 5 when first x is equal to 2, x is equal to negative 1, x is equal to 0, and x is equal to 1/2. But I want you to write it out like this for me, right? With the substitution in there. Use brackets, please. If you do not use brackets, you're going to get something weird, right? Because if I were to just substitute 2 into 12x plus 5 without using a bracket, I will just get 1, 2, 2 plus 5, which is wrong. Okay, so you have to use brackets because 12x literally means 12 times x, and brackets mean multiplication. So you're using brackets. And then, so this is 1, and then you're doing another one. You're doing for me h of x, and remember I told you, you can use any letter to represent a function. It doesn't just have to be f. F, however, is probably the most popular one that we use in math, but functions can be, you can use any letter, right? So let's say we're using h of x, and you're doing for me, h of x is equal to x squared minus 3, all right? And you're finding for me, find E, you're looking at f of 1, f of negative 3, f of 0.4, and then finally f of negative 5. All right, guys, so you're doing these for me, and I want to see everybody's work, please. Please send it to me on WhatsApp. I am stepping away from the computer for a few minutes, but I'm expecting every single one of you. I want to see your work I want to see your work in for each of these questions, please. Thank you. And if you're having trouble, don't worry, just at least try something. All right, and I'm going to go through it afterwards. All right, so
Miss, I have
please.
one more.
Okay, would you like me to wait for you? Or can I start? Because I think by the time
You could
I will.
watch.
Okay, good. You'll correct in your book as you go along, right? I saw your work, so I know that y'all did it. So, even though you're still working on it, Jenny, still send it to me, okay? Because I want to see it. Same thing with you, Zafi. Still send
Send
it.
it now.
Yeah, you can send it now. I'll check it after. Right, guys. So for the first one, f of x is 12x plus 5. Find f of 2. This will be, well, wherever we have 2, we're going to replace it. Wherever we have x, sorry, we're replacing it with 2. The function is 12x plus 5. So that's 12 times 2 plus 5. And how you'd write it, which is very important, and I really wanted to see that. Everybody make sure you have all your steps. It'll be 12 times 2 plus 5, which is 12 twos are 24, and 24 plus 5 is 29. And then f of negative 1, so that will be 12 times negative 1 plus 5. That would be negative 12 plus 5, which is negative 7. F of 0, 12 times 0 plus 5, so that's 0 plus 5, which is 5. And then finally, 12 times a half plus 5. So a half by 12 is 6, and 6 plus 5 is 11. So far, I think everybody got those correct. All right? F of
Excuse
1.
me, miss. Sorry
Yay.
to interrupt, but I don't know if you got my my second question because my internet wasn't working well.
I got it, love. I just saw it. Yeah. Wait, let me see. I don't think I got all actually. Let's see. No, I did. Yeah. Right. So f of 1, that would be 1 squared minus 3, which is 1 squared is 1 minus 3. 1 minus 3 is negative 2. F of negative 3. Now, guys, here you have to be careful, right? Negative 3 squared will be minus 3 in brackets, all to be squared minus 3. So minus 3 times minus 3 is 9, right? So this will actually be 9 take away 3, which is 6. All right? So make sure when you are writing it down, especially for squaring, make sure you put it in brackets like that. Okay, so that would be minus 3 squared, which is 9, and then 9 take away 3 is 6. All right, and then you have f of 0.4, so that would be 0.4 squared minus 3. 0.4 squared will be, what's that, minus? Sorry, not minus, that'll be 0.16 because 4 squared is 16. So that's 0.4 squared minus 3 will be negative 2.84. And then finally, negative 5 squared. So this will be in brackets minus 5 all to be squared minus 3. And that gives me negative 5 times negative 5 is 25. And 25 take away 3 is 22. Now, guys, here I want to use this opportunity just to draw your attention to something, right? Now, if I have negative 3 all to be squared, this means minus 3 times minus 3, which is positive 9, right? If, however, I had a minus on the outside here, and then I had minus 3 all to be squared, this will be equal to, well, you have your negative. Remember, when you have brackets, because of BODMAS, because of the order of operations, you work out your brackets first, right? So this will actually be negative 3 times negative 3, but you still have this negative on the outside here. And I want to really draw your attention to that because this is a source of real conflict for students. You still have this minus sign on the outside there. So this will actually be minus 9. Here does not minus 3 squared does not change to these two minuses does not change to a positive. Okay, That's incorrect because you cannot do the multiplication on the outside here, meaning that you cannot multiply the negative by the negative before you work out what's in the brackets. Because by our order of operations, BODMAS or PEMDAS, however you know it, brackets comes first. So if you have a minus on the outside, you have to apply that minus sign after you work out what is inside of the brackets, okay? So please be careful with that. I see it all the time when students will do minus, and a minus is a plus. That's wrong, right? Well, not wrong in general. A minus by a minus is a plus. But if you have minus -3 all to be squared, you have to do the -3 squared first, which will give you +9, and then apply the minus sign. So then a minus by a plus will give you a minus. Okay, so please, you can write this down as well, right? This minus sign on the outside will remain as a minus on the outside. If you had if you had 9 take away -6, now this is where the minus and the minus will change and it will become a plus, and 9 plus 6 is 15, right? But if you had 9 take away -6 all to be squared, you would have to work out -6 all to be squared first, right? So you'll end up with 9 take away -6 all to be squared is 36. And that would give me 9 take away 36, which is -27. So I need you guys to be mindful of that, okay? It's not going to be 9 take away -6 squared is not 9 plus 36. This is wrong, okay? This is wrong. This is correct. So I want you all to really understand that your rules of your order of operations, BODMAS, I know you learned that in Form 1, but it still applies forever, right? It's not something that you just, you don't apply. It is something that applies in every single calculation that you make with multiple operations. It follows the laws of any problem that includes multiple operations must follow the order of operations. And that is brackets first. All right. So guys, you can also have, you can have a rational function. And what do I mean by a rational function? I have a numerator and a denominator, right? So I could have the function f of x is equal to x plus 2 over x plus 3, for instance. The same rules apply as if in the fact that I want, let's say I want to find 5 by 5, sorry, why did I say 5? F of 2, right? F of 2 is found by substituting x is equal to 2 into the expression. So wherever I have x, I'm going to replace it with 2. So this will be 2 plus 2 over 2 plus 3. All right, and that gives me 2 plus 2 is 4, and 2 plus 3 is 5. So therefore, f of 2 is equal to 4 over 5. So it still applies, okay? A function could literally be anything. So you can, let's say so this is one function. This is called a rational function. It's called a rational function because it is in the form of a fraction, right? Where you have a numerator and a denominator. You can also have, I could have f of x is equal to the square root of x, for instance, right? So if f of x is the square root of x, let's say what will be f of 4? Well, f of 4 will be the square root of 4, which is equal to 2. Or f of 100, then that would be the square root of 100, and that is 10. In all of these, it will be plus or minus, by the way, because the square root could be plus or minus, right? So it could be positive 10 or minus 10. So the function could be anything. It could be any set of operations string together, okay? Now, generally, the domain of a function, let me see, hold on, let me just check back the notes because I think I have the domain here. Oh no, we're coming up to that just now. Right, so in all of these examples that we've done, we have looked at finding the value of the function when given a x value, right? But we can also find we can have what the function is equal to. So like what f of x is equal to, or what the image is equal to. And we can find the value of the number in the equation. So what do I mean by that? Let's say I have a function if g of x is equal to 5x plus 6, for what value of x is g of x equal to 41, right? So all of these we were finding, we had what x was, and we needed to find what in this case g of x is equal to. But here I am asking you, what is the value of x when g of x is equal to 41? So all you do, girls, we already know we know the expression for g of x. We know what the rule or the relation or the connection is. We know that that is 5x plus 6. So I am asking you to solve for x when 5x plus 6 is equal to 41. So what we do is we say 5x plus 6 is equal to 41, and then you solve for x, right? Because g of x is 5x plus 6. So if g of x is equal to 5x plus 6, then that means and so if g of x is equal to 5x plus 6 and g of x is 41, then it means that 5x plus 6 is equal to 41. So let's find out for what value of x will I get 41 for g of x. All I do, girls, is I solve for x in this equation. So this would be 5x is equal to 41, take away 6. So that means that 5x is equal to 35. And so x is equal to 35 divided by 5, which means that x is equal to 7. And just to show you that it's correct, this means that x is equal to 7 when g of x is 41. So, therefore, if I were to find what g of 7 is, I should get 41. So, finding g of 7, I would say 5 times 7 plus 6, because that's what g of x is. That's the function that defines g of x. So, 5 times 7 is 35, and 35 plus 6 is indeed 41. So, x is equal to 7 when g of x is equal to 41. All right, so let's look at another one. Let's say if find x when h of x is equal to 3x minus 1. All right, so again, when h of x is equal to when h of x, I almost set you all up there, yes? When h of x is equal to 31, if h of x is equal to 3x minus 1. All right, so to find what x is, I will say 3x, that's h of x, 3x minus 1 is equal to 13. And then I solve for x. So 3x is equal to 13 plus 1, which means that 3x is equal to 14. And so x is equal to 14 over 3. You could leave your answer like that, or you can write it as a mixed number. That would be 3 into 14 is 4, remainder 2, so 4 and 2/3. Right? So this is how you will do a question like this. And again, to check to see if your answer is correct, it means that when x is 14 over 3, h of x should be 13. Look, h of 14 over 3 would be equal to 3 times 14 over 3 minus 1. I should get the answer as 13. So the 3's could cancel, and that'll be 14 take away 1, which is 13. So you see, my answer is correct because when h is 14 over 3, or when h is 4 and 2/3, x is, when x, is 14 over 3, h of 14 over 3 is 13. All right, so whenever you have a question, ladies, and they're asking you to find the value of x instead, you equate whatever the function is equal to that number, and then you solve for x. All right, so let's say find another one. Find x for f of x is equal to 5x plus 2 when f of x is equal to 22, right? So what we would do is we're going to say, well, if f of x is 22, that means f5x plus 2 is equal to 22. So then 5x is equal to 22, take away 2, which means that 5x is equal to 20, and so x is equal to 20 over 5, which means x is equal to 4. All right, girls? So to find what x is equal to, this is how you do it. You would just write the expression, the function, equal to the value that they gave you, and then you solve the equation for x. So I want you all to try one for me. Okay, so the function is so you're considering the function, consider f of x is equal to 3x plus 2. Find x if f of x is equal to 20. Try this one for me, please, girls. All right, girls. Thank you for those of you who sent it. Isabel, I got your message, okay? You need to delete some stuff. Right, so this is 3, if f of x is equal to 20, that means 3x plus 2 is equal to 20. And so 3x will be 20 take away 2, which means that x is equal to, 3x is equal to 18. And so x would be 18 divided by 3, which is 6. Beautiful. To check if your answer is correct, you can substitute 6, x is equal to 6 into f of x to see if it's equal to 20. And it would work because 3 by 6 plus 2, 3 times 6 is 18, and 18 plus 2 is 20. So it works. Okay. How we going there, girls? Let me get a vibe check from you all. Athena, how we going so far?
I was a little bit confused on this one, but overall, I was good.
Okay, in this one, in terms of like in this part where you have to find the value of x.
Yeah, just specifically this part right here. I was good with the other ones, but
Right.
it's just this one.
Okay, so when we have to, no problem, let's do some more like it, right? So the steps basically what this is asking us is, all right, so before, right, in all of the questions before, we were like, if you have the mapping diagram, so let's say we have f of x, and we're going to use the same one. F of x is 3x plus 2, right? initially, we were looking at finding the values of f of x when x was equal to a certain number. So for instance, if x is 2, then f of x will be 3 times 2 plus 2, right? Which is 3 times 2 is 6, and then 6 plus 2 is 8, right? Tina, what about if x is 0? What would f of x be equal to for this function?
If x is equal to 0,
Yeah, what would f of x be equal to?
um, it would just be 2.
Yeah, it'll just be 2, right? Because it'll be 3 times 0 plus 2. You're right. It'll just be 2, right? Hold on, first of all, I want to change this color because I don't want to write in red. So f of 0 will be equal to 3 times 0 plus 2, which is 2, right? So that's how we got that. And that's fine. You're fine with going from x, finding the value of f of x when x is equal to something. But I'm asking you, this part, this second part that you're saying is a little confusing, is like if we knew what this value was equal to, and I wanted to find what x is equal to. So we go in backwards instead, right? So in other words, if f of x is equal to 20, then what value would x be, right? But the only information we have here is that f of x is equal to 3x plus 2. So if f of x is equal to 20, then we are actually saying that 3x, whatever that x is, when we add 2 to that, it gives us 20. So now we're working backwards. So we're working from f of x to get x now. So for a simpler function, Athena, like if it was the first one, like which you were able to identify very clearly, actually, 'cause you answered it for me. When I had f of x was 2x, right? And I had 1, 2, and 3. You were able to see that the function here is f of x is equal to 2x. So if f of x is equal to 2x, right? If f of x is equal to 2x, then that means when x is 1, f of x will be 2. When x is 2, f of x will be 4. When x is 3, f of x will be 6. Athena, still with you here, right, honey? Follow with me. If f of x was 8, what would be x?
It'd be 4.
It'll be 4. What about if f of x was 20? What would x be equal to?
10.
It'll be 10. Now it's easy to just see it, right? Because the function is simple. But I can work this out algebraically as well, right? I could have said, well, if f of x is equal to 20 and I want to know what x is, well, I could solve it using algebra because I know that the function f of x is defined as 2x. So when 2x is equal to 20, x would have to be equal to 20 divided by 2, which is 10. So that's how you got 10. And that's how you also got 4. You worked it out in your head. You didn't write it out, but you worked it out in your head because you worked backwards, right? So in the same way, if I know what the function is, if I know that the function f is defined as 3x plus 2, and I know what the value of the function is, then I can find out what value of x is responsible for giving me that value of the function. So in other words, when 3x plus 2 is equal to 20, I want to know what x is equal to. So when f of x is equal to 20, what is the corresponding x value? Well, I would use the expression that is the definition of the function, and I will solve for x. So if 3x plus 2 is equal to 20, then you solve algebraically. It will mean that 3x will be 20, take away 2, and then that means 3x is equal to 18, and so x is equal to 18 divided by 3, which is 6. Does that make a little sense to you, Atina? We're gonna do one together
Yeah.
next. So let's do one together again, okay? So we are working to find out the x values now. So this x is 6. All right. So let's say that we have the function f of x is equal to 5x plus 1. All right. And I want to know for what value of x is f of x equal to 41. Right? So I want to know what value of x gives me 41 when f of x is equal to 5x plus 1. So do you remember the steps, Latina, was what we need to do to begin to solve for x?
So you gotta work backwards. So basically you're minusing the 1 from the 41.
Right. So
You
let's
get
first of all, but that's correct. I love that you have that in your mind. But let's write out the equation, right? So let's write 5x plus 1 is equal to 41. And yes, you're correct. The first thing would be to minus 41, 1 from 41. Good. What would that give me?
that'll give you 40.
Right? So then if 5x is 40, x would be equal to
8.
That's right. 40 divided by 5. So x is 8. Does that make sense, love?
Yeah.
All right, good. Thank you. Let me see. Who else? Ari, how are we going there? Where is my girl, Ariana? All right. I don't know where Ari is. Genesis. Genesis, is this okay? Everything so far is okay for you?
Yes, miss.
Perfect. I see that because I think you got all correct in the questions that you sent me so far. Zafi, how's it going? Now that's we
It's a
went
lot
through the
better.
great, beautiful. Kaylin, is this okay? Anything confusing you want me to go over with you?
No, this is okay.
All right. I know you all did functions before, so this should be a little bit of revision for you. What about you, Nia? Nia, how are we going?
We are wonderful. Very
Beautiful.
wonderful.
Isabel, how's it?
It's good.
Right, good. I think I asked everybody. I don't know where Ari went, but I assume that Ari is going good as well. Oh, Ari's having a little trouble. Okay, it's her internet. All right, no probs. Girls, we're gonna stop there for today. Here's what. I am going to send you all a worksheet on everything that we did so far. Y'all tell me, what is your preference? Do you want me to send you like a Google quiz that you can actually like take it like a quiz basically, and then you would get back your grade immediately? Or do you want me to send you something written? What is your preference?
A quiz.
Google quiz. Because you have to work it out
Quiz.
anyway. You would have to actually work it out. So yeah, so what I'm gonna do is I'm gonna create a Google quiz based on everything that we did today, and I'd like you all to do it anytime before next week, Monday. Is that okay, girls? And
Yeah.
you can do it on your phone or on your computer. You will need to work things out. So you would need to like write out on a piece of paper. You have to write out your solutions. And don't throw it away because I would like to see that as well. If so, here's what. I'll do the Google quiz. Oh wait, let me stop this recording. This is unnecessary for the recording.